In this tutorial, we'll learn how to use the Latent Semantic Similarity plugin for the Butter text analysis software. What this plugin will do is take transcripts that we've already separated using some of these other plugins, and then calculate the latent semantic similarity between each speaker within each transcript on a pairwise basis. Now, in order to use this plugin, you'll need to use some of these other plugins first, and we have separate tutorial videos for each of these other plugins. So here we'll really just focus on how to use this plugin. And for some of these other ones that you'll see us using, you'll want to go and look at the separate tutorial videos for those plugins. Now for this example, we'll use the Cornell movie corpus. So this is a version of the data set that I have that has these transcript files. And each transcript is a pretty standard format. We have speaker names, or the speaker tags, and then the text that belongs to each speaker. Now the way that latent semantic similarity works is that we use some kind of a pre-trained word embedding model. And these usually in a standard format look something like this. So I won't go into too much detail on everything that you're seeing here. Just know that the first line has two numbers on it. We have the vocabulary size. So in this file, we have vectors for 92,393 words. And each word is represented by a 300-dimension vector. Now you can train your own models from Butter using something like the Word2Vec plugin. And you can also find online a number of pre-trained word embedding models. So this is a pre-trained TASA model that's based on a bunch of student texts and things like that. I think they're mostly primary school and maybe some college level readings where someone has already trained this model. So we'll go ahead and use this pre-trained model. And essentially the way that works is it goes through each of these transcripts and then looks up every single person's words in that model and then gets the average vector across all of the words that each person uses. So each person ends up with a single average 300-dimension vector. Then, for latent semantic similarity, go and calculate the cosine similarity between each person's vector in a text. That might be a bit complicated. If you're not really familiar with all of these models and the types of analyses that I'm talking about here, there are a lot of really good resources online. You may also consider checking out a couple of these papers here that I have in the description text box for some more information on how to interpret this output. At the end of the day, just know that essentially what we're doing is we're taking the text for each speaker in a transcript and calculating how similar is each person's text. Are they talking about the same things in general? So what we'll do is we'll go ahead and load in these transcript files that I have. Then we'll separate out the text for each speaker. Now I've already gone through and used the Detect Speakers and Transcript plugin to get this list of speaker tags so that we can identify and separate the text for each person in each of these transcript files. And again, if you're not sure how to use this plugin, go ahead and watch the tutorial video for this one first. And also know that you don't have to follow this exact pipeline setup. If you have, for example, a CSV file that has different speakers' texts, like this one here, and I might need to reformat this file a little bit. Let's just change it so it's a little bit more legible. There we go. That didn't work as well as I'd hoped. Row height 15, there we go. So here we have every row has a separate movie, and each column has the text for a different speaker. So if we want to read in this CSV file and calculate pairwise latent semantic similarity, or LSS scores, between text 1 and text 2, text 1 and text 3, and text 2 and text 3 for each row, we can do that as well using some other plugins like the Read Text from CSV and the Group Data Packager plugin. Now again, there are separate tutorial videos for these if that's more the format of data that you have. For now, we'll just stick with this format. So we'll load in the texts, we'll separate out the text so that we have a separate text for each person. Now we need to calculate the latent semantic similarity scores. In order to do this, we'll go to the settings and we'll just choose some of the basic information about that pre-trained model that we looked at earlier, this one here. So really, in order to use this plugin, you only need to know a couple of things. You'll want to know what your file encoding is. For most people, this will be UTF-8. This is a pretty common or standard file encoding. If you know that your model file has a different encoding, you can change that with this drop-down menu. And then we'll just point this towards our model file. So for me, I have this file here, tacit.txt. And that's what we were looking at earlier, this big text file that has all of these words in it with the vectors for each word. So we'll just go ahead and open this up. And we can see it's done a couple of quick checks. These numbers here match those numbers at the top of the file. 92393, 92393, 300 dimensions. So we know that this matches up. And that's all we have to do to set that up. And then we'll choose where we want to save our output. I'm just going to make a new file and put our output, we'll call it LSS for latent semantic similarity. And let's go ahead and get this running. And this plugin will take a little bit of time to initialize because it has to read in that entire model file so that we can analyze the texts fairly quickly. Depending on the size of your model file, if your model file is several gigabytes large, you may need to set aside a bit more time for your plugin to initialize as it has to read the entire file in. If you have an exceptionally large model, you'll also want to make sure that your computer has enough memory to be able to hold that entire model. This plugin is fairly memory efficient, so it doesn't require too much overhead. If you have a model file that is maybe 2 or 3 gigabytes large, it doesn't need a whole lot more memory than that to hold the whole thing at once to make text analysis fairly quick. However, just know that if you have a computer that has more modest specifications, you'll need to figure out how to work with a smaller model file. And you can see this is finished now. Once it actually loaded up the whole model, it was pretty quick. So let's go ahead and look at what this output looks like. So this is pretty easy to interpret. Let's zoom out just a little bit. So for text ID, we have the file. So each one of these rows that you can see here all belongs to the same transcript file, M584. Let's go ahead and sort this so that we look at this file here, M0. And the output is pretty easy to interpret. For this segment, this tells us what pair of people does this LSS score belong to. So we have person 1, Walter, and person 2, Bianca. So these numbers here tell us everything about what this row, what data this row belongs to. So we have the actual latent semantic similarity score between these two speakers, Walter and Bianca, within this transcript. We also have the number of words captured by the model file for each person. So this is a little bit different than an actual word count. This is the number of words that we have for Walter, P1, and the number of words for Bianca, P2, that we were able to find within this model file that we used. And that's it. That's how we use the Latent Semantic Similarity plugin for Butterfly.